At MFGS Inc., Micro Focus is exclusive master supplier to the U.S. government. We help you run and transform your agency in a changing world. With a holistic set of solutions backed by a robust analytics system, our customers are addressing the 4 core pillars of digital transformation. Our mission is to provide your agency the ability to bridge the existing and emerging technologies, allowing you to move faster, have greater agility, secure what matters most, and surface critical insights, all while removing the need to take a risky rip and replace approach, so you can run and transform at the same time. At Micro Focus, we call that smart digital transformation. For more information on how MFGS Inc. can help your agency, please visit us at mfgsinc.com.
Wright Pat is home to the 445th Airlift Wing under the Air Force Reserve Command. The 445th is comprised of an Aerospace Medicine Squadron, Aeromedical Staging Squadron, and 3 attached groups. Consisting of approximately 1,700 officers enlisted and civilian personnel, the wing currently has 9 C-17 Globemaster III aircraft and conducts an average of 47,000 aircraft operations every year, including recent missions in Afghanistan. I hope you enjoy this panel on IoT realization.
Good afternoon, class. We're going to get started. So I know my job is very simple. I'm responsible for keeping you awake for 50 minutes. I know it's second day of the conference, after lunch, late afternoon, but it's going to be very easy for me because we have a very exciting topic and wonderful presenters from 3 very prestigious companies. My name is Indu Singh. I'm senior scientist at OST Inc. I'm responsible for digital transformation and cybersecurity on behalf of my company. I've been doing this for some time, and I want to share a few things with you. I'm not going to talk about technology because you have plenty of that, and you will have more of it. Topic is IoT, a realization, and our approach is through case studies. So you will have the people who are going to talk about, give you the case studies, the things that they have implemented, challenges that they have faced, and what they think the opportunities are, and the lessons learned. So this is a very practical approach to really learning IoT. Now, we had a great day yesterday. I felt like I spent 4 months on a college campus, enlightened. This morning, we had a great start, the topic of digital transformation, right? It's a very exciting time that we are facing. IoT is a critical element of digital transformation. And so what I want to start is not talk about the technology, but really look at it, what's happening at the society level, both here at home and globally, and what it means in terms of interconnecting IoT to digital transformation. So may I have the first slide, please? So, and this is the non-technical part. As a society, I believe that we're going through 2 dynamic changes that are taking place in parallel. And oftentimes, we are focusing on one thing and ignoring the other. So I was very excited when the Air Force CIO gave the presentation where she said that digital transformation is a journey. Truly, it is a journey. It will never be a destination. We should keep that in mind. It is also a journey that did not start today or in the 3rd decade of the 21st century. Oftentimes, we feel like all of a sudden, everybody's talking about digital transformation as if it just happened. I'll tell you that it didn't happen. I was doing the same digital transformation 30 years ago. It tells you I'm old. So what is different today that it was not 30 years ago when I started digital transformation through a program called Smart Cities? I was the guy who designed the first model smart city in the world, Singapore Intelligent Island. Okay? That was truly a digital transformation project involving 14 sectors of the economy at the city-state level. And since then, we have done multiple projects. I run 3 labs for my company. We have a corporate lab that is called COEI, Center of Innovation and Engineering, where we have multiple partners. PTC is one of the partners in that for our IoT platform. I also run a lab called a Smart Airport Lab under CRADA with the FAA, where we're developing solutions for designing and building smart airports. The Stafford Smart City Lab is very unique. This is the first test bed, actually a smart city test bed in the country, where we have the 5G working with Verizon. We're doing interesting thing in the area of drones, AI/ML, cloud-based IoT, zero trust, and all other things. But framing this concept of these two dynamic forces of change that is happening today in the United States, but also globally, what I call the digital transformation and cultural transformation. I was very moved by Jordan's presentation, because he's the one in 2 days has ever uttered the word called culture. He did, right? And I strongly believe, whether it's the Air Force or whether it's the civilian sector or the state or county or commercial, if we engage in digital transformation and not take into account the simultaneous cultural transformation that is taking place, we will fail. And so a proper balance between the two, that's what Jordan was saying, and I'm very much aligned with his thinking, is going to be very critical. Digital transformation is not the same thing as IT transformation. And if any organization that believes that digital transformation is transitioning from IT transition, that conceptualization is wrong also. It is a very different things. But anyway, the moral of the story is that these two forces interact, but they also collide. At times you will find when you're doing the digital transformation that the cultural forces and technological forces really do not align. And then you have to find the proper balance. So what are the factors that's driving this? Next slide, please. So if you look at these factors, we have talked about that. I do not want to spend time on this, but these are the things that is really driving and will continue to drive digital transformation. And not just the technology, just look at the couple of the cultural to techno-cultural revolution. What have we done? We are integrating culture and technology, more so today than ever before. And that's a big paradigm shift that is taking place. New technology, 5G, cloud, AI/ML, these are all going to drive our concept and implementation of digital transformation. But before I came here, and this is the last thing I want to say, before I came here, I decided to read 2 books, which I read when I was in graduate school, by Toffler, Future Shock and Power Shift. And I wanted to really refresh and relate to what is happening today in terms of what he said. And I really suggest that if you get a chance, read those books. You'll find them very refreshing. Toffler, in both books, his concept of the future shock and power shift was really built around digital transformation. That's what he talked about. So we can learn a lot from those old writings that really exist. So what do we want to do? My last slide, third slide, please. Yeah, so our first presentation is by Gardner. Al is very well respected. He knows what he's saying, and he's going to really paint the high-level picture of what's happening in the marketplace in terms of IoT implementation. Then I'll request my friend here, Ian, to come in from PTC. They have multiple cases that they want to share with you. They are one of the leading players in IoT. And then the last but not least is Tom. Unfortunately, he couldn't be here today. He's also virtual like Al. And he's going to share his experience, his company's experience in implementing IoT. So I'm going to hand over to Al.
Thank you very much, and really do appreciate that. And for everybody, greetings from Arizona. I have a strong love of Ohio. I was sharing with Tom earlier, I met my wife in Cleveland a long time ago when I was young and my knees didn't hurt. So just a bit ago. What I would want to highlight today is that I'm going to share a few lessons that I've seen from the market. So this is a deployment across all sectors. So it's not just DoD environments, but it's across all sectors that I'd want to highlight to you. And The thing that I would really want to emphasize, if I start with the next slide, which is the one that IoT creates a window into our things, is really it's about how we see the world now that we have this capability. But it's like we just said, it's about digital transformation. It's about how we change what we do to make it better using the technology. And so the key part of this is always going to be about the people. So we're going to get a window into our assets, whether it's a fighter that is driven by a war fighter, or alternatively, it's one of our consumer assets, as you see the car or the light there. It's really about how we can see that and operate it better. But what I would ask you as you think about this is, as we move to the next slide, right? When we think about this, what I would ask you to sort of channel for a moment is just think about when we were kids and we were watching Lucille Ball. Remember the chocolate episode, right? And the 5 million on this slide sort of emphasizes it. Right now, we're at the beginning where they haven't changed the flow of the chocolates along. But once we hit 5 million new IoT enabled assets per day, we really are going to have processes, a need for processes and structure on our side to address this. How do we deal with this? Because remember, at the beginning, she was just packaging the chocolates, but all of a sudden, when the line moved up, she was like putting them all over, then all that. This is the challenge we have. How do we actually make sure we support our organization as it's moving on this journey while at the same time dealing with the people issues? So what I'm going to talk to you about today is a little bit about why people are doing this. I'm going to highlight a very high level architecture, talk about the team. And for those of you in the DoD in particular, I'm going to talk about budgets. Surprise, surprise. Who knew, right? And then I'll end with barriers. So next slide, please. Let's talk about a very high level architecture. And what I would emphasize to you here is we're going from the asset to the edge, to the cloud, to the stakeholder. The most important part of this is the stakeholder. Now, let me be clear to you, right? Ian and Tom, they're going to go into architecture way more detail, but I want you to just sort of grok this for a moment. We're really dealing with that stakeholder. What job does he or she need to do? What do they actually need to do? How do we support them on that? And if you click on the build for the next level on that, what you also see is the fundamental here about that distributed data and computing topology. We're going to have data, we're going to have compute security, all these elements, peanut buttered all the way through, all the way from the asset to all the way to the application that stakeholder, whether it's a warfighter or it's a regular citizen doing their job, or us as consumers playing with something or working with something that we do. So this is one of the fundamental uh, issues that we see here. We need to understand that architecture. And we also need to understand that most data has a specific value that's driven by that stakeholder. That data is only valuable, for example, either in a millisecond on the asset, so it needs to be applied and processed strictly on the edge on the asset. Maybe it's a few more seconds, so it could be on the edge itself. Or maybe it's something that really requires contextual data from other environments, whether it's weather, supply chain information, et cetera. So that's where the cloud comes in. So we need to understand, what does a stakeholder need and how that applies to the job that they're doing for their environment, and how we support that with our architecture, right? That determines what kind of event architecture, what events are important, what we need to do here, and where we're going with that. But it also determines other things that we put in, again, compute resources, but also the type of, say, IoT platforms on the edge, the other resources that go with that, but also what other applications we're going to plug into to, again, support that stakeholder and the specific job that they're doing in their environment. So if we take this architecture and we center it on that stakeholder, next slide, what I would emphasize to you is it comes back again to the team. We know this, but we need to make this extremely explicit. And there's two ways that I would ask you to think about it. If we're approaching this, for example, from buying an IoT solution, there will be multiple stakeholders, for example, in IT or in the specific operations or engineering, or maybe even at that management level, at the general or admiral level, that have specific requirements. Now, it will be a senior business leader, a senior military leader who drives the budget for any DoD project, and they have the approval for it. But we need to make sure that the different stakeholders are involved in the decision because we don't want somebody later to come in, wait a second, you didn't think enough about security, there's this gap here, or alternatively, you didn't think enough about integration, there's these issues. So that's one part. But the other thing is, as you see, for each of the roles I have here on the slide, there's specific jobs they contribute, whether it's thinking about the goals and laying out the goals that we need to meet for the organization, whether it's in terms of the types of missions a wing needs to run, how we manage munitions, or alternatively, how do we take this building and lower its energy consumption, right? It depends on the goals that were set, the specific tasks, and the KPIs they give us that we need to meet for those goals. At the same time, when you think about the operations team, they're the ones actually running the environment. They understand the functionality, they have the job. They're actually, in most cases, the key stakeholder that's actually operating the environment where the IoT solution comes in to support. So they'll drive elements in terms of operations, specific tasks, etc. They'll also need a really good user experience. And so these will be some of the things that we're going to hear about in the subsequent environment conversations. But I'll also emphasize that IT is fundamental. IT brings everything from a thought process around data. How do we manage software assets over time, right? Because we're not just implementing an IoT solution and we can say, oh, bye-bye. I forget you already because it's all good. No, it needs to be supported over time and it needs to be managed, right? So the software itself needs to be managed, but then the software assets, the entities that spin off from that, digital twins that come out of that, they also need to be managed, and the metadata of them needs to be managed and integrated into our other thought process for our integration at the broader scale in the organization. So IT comes in and brings a whole host of key capabilities that we have to think about. So altogether, this is the team that's needed. If we don't have one of these elements of this triumvirate, it won't really work because we need each part of this to drive the specific tasks that they contribute to how we succeed. But the other thing is, as we highlighted earlier, it's not a destination, it's a journey. So it's about people working together to change what they're doing, to set new goals, to continue to evolve. Once they see the capabilities, oh man, look at what we did here. Why don't we do this over there, right? Getting those gifts of people, their ideas, and applying them to the next task. That's actually something that we consistently see for organizations who are deploying this. But it requires, again, senior leadership, the engineering and operations team, and the IT team. Okay, but if we're doing this, next slide, please. What this means is we need to actually have a thought process where we're thinking short term and long term. And unfortunately, too many organizations only think short term. What I would emphasize to you is obviously, yes, we have to think about the initial contract, who we're working with to design the environment, to implement the environment. But that's just the short term. And in fact, what I see here is usually just 3 to maybe 5-year contracts, just to be clear to all of you. But, and if you finish building out the slide, please. What I really see in the leading edge set of folks is they understand that this is really a long term. I initially start with this 3-year contract, and it may be for a smaller deployment. But as I really look at all the things I can do, whether it's working on a specific environment for the warfighter or solving a specific business operational issue, for example, in buildings or in supply chain, I need to understand that I'm engaged with this solution and therefore this partner, right? Because I'm buying a solution from somebody for a very long time. Normally, when I talk to companies, I try to ask them to think about this on a 10-year horizon, because that's going to be really for any good IoT deployment. That's the kind of mentality that I see. That's the kind of deployments I see. But I would also ask you to think about is, again, we're going to have these people bring their gifts, their ideas, and come up with more thought processes. So you see on the bottom of the slide that I highlight that there will be add-on software that will add on things called packaged business capabilities, basically apps that we build on top. So for example, a leak detection app or a location app that's built on top of my platform, or I add on other software, say analytics or something else, to support the mission of that stakeholder. So the budget is quite fundamental. But next slide, what I would also highlight to you is I do see a significant number of challenges to the environment. There's serious barriers to adoption just because when I'm working with organizations in this space, we see a series of technical things. That's the easy thing to see in IoT because so many of us are engineers. We'll see the issues in terms of the technical complexity, security, integration. But when I'm talking to the senior business leaders, whether it's on the DoD side or in the commercial side, in the industrial side, the senior leaders understand it's really the business issue that I have. Is my talent appropriate to this? What do I need to do to take my talent to that next level? How do I change my business culture to actually use this? And then actually, what else do I need to do to draw to the next level? How do I give them guidance? How do I these are right now that challenge a whole range of organizations from the US all the way to Japan in terms of how they truly deploy this and get the real benefit for their organization and for their stakeholders. So this slide, please. I would emphasize, just to sum up, and then we'll get into the real meat from both Ian and Tom, is that you need to have a team. So the center of excellence, that's a fundamental starting point for anybody. You'll need to think about, as we continue to go along and you continue to build out your capabilities, what's going on in terms of gaps. What do I have? Where do I fix a gap, whether it's people, technology, or some of the business challenges we have to make sure that this is relevant to our organization. And some of those we can address internally. Others we can address with technology, say the architecture, and yet others we have to make sure we address with partners. The last thing that I'll emphasize, though, is that you'll have to think about both a short-term and long-term roadmap, because you have to start and show success in the short term with smaller projects, and then start to ramp up and really deploy this at scale at the organization. So building a roadmap that lets you show success using solutions from companies such as PTC and IBM, but also that has clear sets of metrics so we can identify when we've met with success, so we can communicate that and communicate that repeatedly with the organization. Again, it's about the journey, and when we're on a journey, we have to communicate constantly with ourselves, especially as the goals change over time. And with that, I thank you and hand back to you, Indu. Thank you very much.
Our next speaker is Ian.
Okay, good afternoon, everyone. My name's Ian Bolton from PTC. We're a software company based in Boston, Massachusetts, and we specialize in commercial off-the-shelf digital transformation solutions aimed at digital engineering and then pushing that digital thread through into the factory, manufacturing, condition-based maintenance, all those good things that Industry 4.0 can enable. I wanted to talk a little bit about our approach to IoT and how we implement it in industry, and then potentially how that could be leveraged or focused at things like depots in the United States Air Force. So typically when I talk to our commercial customers, the thing that drives their adoption of Industry 4.0 or Industrial Internet of Things is essentially lean processes, or the ability to essentially reduce scrap, increase margin, increase productivity, enable workers quicker, or enable those workers to be more efficient quicker. So typically, a business case to implement IoT would be driven by things like margin improvements or reducing labor or material costs. That can be done by reducing the scrap or allowing you to better manage your materials that you supply into your manufacturing processes and remove bottlenecks in those processes, and then drive up the efficiency of your plants. Again, the industry, IoT really is a lens that allows you to kind of change the focus of your business operations. So when you start connecting these different assets and you start looking at the data and analyzing the data and creating dashboards for all of this data that's coming off the assets in a factory or in a depot, it really gives you unique insights into the business operations and where the bottlenecks may exist in those operations. And that's really what I see most of all, is why do our customers adopt IoT? It's essentially to look at their processes, understand them, and then figure out ways to improve them or make them more efficient. We tend to think of the industry IoT platform as a solution that enables you to connect, so to connect to things, and those things can be CNC machines, autoclaves, robots, presses, any type of piece of equipment that you might find in a depot or in a factory, and then build what we call mashups or dashboards, allow you to, once you start collecting that data, you've then got to visualize it, right? So THINGWORX is our IoT platform that essentially has, it's like a low-code, no-code environment that lets you drag and drop widgets onto a pallet so that you can then bind these controls and meters and gauges to actual IoT data streams that would be coming off your piece of equipment, and then analyze that data through supervised machine learning. So another thing that surprises people is the amount of data that one piece of equipment can generate. So a CNC machine from a FANUC or a Makino can generate, I don't know, maybe 1,000 parameters, and each one of those parameters is read out multiple times a second. And so when you start turning on these devices or streaming data from these devices, you quickly realize that the information overload is there and it's going to happen. So what a lot of customers do is apply supervised machine learning at the edge. They filter that data, they pare it down to only the key KPIs that they've decided that they care about, and then they feed and collect those up to the cloud to kind of look at and analyze their business operations across multiple production lines or multiple sites, workstations, depots, or even geographical locations. And then finally, how you actually experience and interact with that data. So a lot of our customers are starting to use things like augmented reality as an alternate human-machine interface. So using things like smart glasses and goggles or iPads in a depot or factory setting, so that you can see what particular job is running on a machine by looking at it through a HoloLens or holding up an iPad and seeing all the specifics around that job and where it is in the process, how much is it 90% complete, is it 60% complete, etc. Our technology has been implemented globally in over 2,000 factories. It is available on-prem or in the cloud, and although I guess Industry 4.0 was pioneered by the manufacturing industry and both the process industry and later in durable goods, we are starting to see it now appear in the aerospace and defense industry. Last year, my team did a pilot with Dr. Meixner, a small proof of concept at a depot in the USAF. It was at Warner Robins Air Force Base, where we're able to, I think, hook up to 4 machines, generate a dashboard for them, lift the data off those machines, and then learn about what that information was actually telling us. So, for example, how many times was the machine operated with the safety interlock guard not in place? It won't actually let you operate the machine, but what it'll do is throw an alarm. And why that's important is if the machine's not working and it's throwing alarms all the time, that means the person that's trying to use that machine doesn't necessarily know how to use it properly or safely. So those are some examples of some of the insights you can quickly get from looking at the data. The other thing that we did through Dr. Meixner was work with AFNIC on certifying the IoT platform. So a lot of people rightly are concerned about security when it comes to Industry 4.0. AFNIC has a process in place to look at software applications that are going to be installed on USAF networks, and we were able to get the IoT platform through that process with AFNIC. So now the IoT platform is actually available for use on USAF networks and is available on the GSA schedule as well. The last thing I wanted to talk about was using the IoT to connect to devices is one use case, but there's another use case that we often see, which is around connecting the people or connecting the workers. And this next example is maybe more focused on what could Industry 4.0 and the technology associated with Industry 4.0? What could I actually do for the airmen working in the depot? Hopefully this video will start playing here. So this is a solution that we call the Connected Work Cell, and it takes different elements of that IoT platform that I was talking about previously. Manufacturing work instructions often come from either PLM or manufacturing execution systems in the forms of bill of material. And within that bill of material, you usually have a build sheet and a set of drawings and a set of instructions that someone should perform. What we do with the Connected Work Cell is we tie all of these things together into one integrated process. So our platform can actually consume data in from PLM or from MES and present that in a multiple forms of delivery at the workstation, either through 2D screen-based work instructions or 3D model-based work instructions. But where you've got steps in a build process that maybe have a pick list associated with parts or torque values, if you use smart tools along with that procedure, so you see the pick list for that bolt there, the green bin is lit up, and then when he says, okay, I picked that part, it now goes red, right? So he's told the job instruction that I picked this 2-inch long bolt for the next step of the procedure. And everything that he's doing at that workstation is being recorded in the background by the IoT system. So I know the operator, I know what workstation he's at, I know what step that he's on, and I know he's picked 2 of these hexagonal bolts that are specified in step 2 and step 3 of this procedure. I also know he's going to torque these bolts to 15 Newton meters because it says that in the work instruction, but the work instruction programmatically told that smart tool, that smart wrench right there, to load that 15 Newton meters of torque ready for the application of that torque during the manufacturing process. And then these smart tools can actually graduate the torque curve and actually record what was applied to that hexagonal nut at that part in the build process. So behind the scenes, as this part is being assembled, you're building a digital fingerprint and a digital build certificate of this part or assembly as it moves down the line in the depot. And then this last part is just showing you how we can deliver that work instruction in different kinds of formats. So here we're using augmented reality at the workstation to do what's called a model target. So we look at the part, it recognizes the part, and then it will overlay the rest of those work instructions on the part. So in this example, it's going to walk the operator through how to put this, I think it's a ram air assembly, back together so that it can be reinstalled on the aircraft. But here, using augmented reality, he can skip through the process, he can practice it, he can see how the parts go together, if there's any special tools required or warnings, etc., those can all be thrown up on the screen. And he can actually complete his job through this interface. Again, because it's connected, it's part of the IoT, it will all get reported back to the MES system as being completed when the job's finally done. So those are some of the kind of different tools and technologies that we're bringing to bear in the industry. And even though some of these are kind of early days right now inside the Air Force, my experience has been that companies that supply the Air Force, like Northrop Grumman and Lockheed Martin and others, are well invested in these technologies today. They're used in their factory that produces parts for the F-35, for example. So I think it would be great for the Air Force to see some of this technology adopted in your work centers and your depots. And with that, I'll hand on to the next person.
Thank you, Ann.
Our final speaker is Tom from IBM.
Great. Thank you, Dr. Singh. As Indu said, I'm Tom Gers. I've been with IBM going on about 5 years now, and I've been acting in a business development role as a part of IBM's global business services. Prior to that, I spent 32 years with the Air Force as a career logistician, and I truly appreciate being asked to participate on this panel, but admittedly a little daunted as the token loggy, sharing the stage with these esteemed technologists here on this panel. But that said, from a career logistician's view, it's a very exciting time to be in this business. And The opportunities presented the last few days are literally unbounded in their potential application across the Air Force sustainment community. So I'm equally excited to share some of our experience in the IoT space here this afternoon. We can go to second slide, please. As we've been discussing this week, Industry 4.0 technologies like 5G and edge, robotic processing, AI, ML, IoT, they act as the main catalyst to ignite intelligent workflows across an organization's business lines. Feeding on the data collected in the enterprise business platform, these improved processes accelerate user capabilities across the full spectrum of business decisions. And this kind of transformation not only creates the opportunity to reshape our processes, but also to reshape our workforce and creates a next generation user experience that transitions from a workforce centered on craftsmanship to one of leadership. And I think that's very important for us to understand as we go through this. It truly is an intriguing and all impacting movement. Next slide, please. So as we think about how to leverage the emerging Industry 4.0 capabilities in an integrated approach, we see the IoT-led digital transformation spanning each of the 6 major technology domains. And we've talked about each of these largely in the last few days. Cloud and edge computing, AI and machine learning, digital twin, all working within a cyber-secure network seamlessly interconnected by end-to-end IoT capabilities. It's a pretty compelling journey. Next slide. And as we've all recognized, it's not new. The journey's begun decades ago, and each of our clients are on their way somewhere on this maturity curve. And our approach is to meet them on their journey wherever they are on the spectrum, which is defined largely by their existing and planned technology investments. And so to do this, we've positioned our offerings to help clients level up from where they are today. An example of this is how we've aligned our asset performance management suite to help them collect existing asset data, as represented by the manage modules. Connect data for visibility of the asset conditions, monitor modules. Scoring the operational status for managed assets, health. And then bringing in unique analytics to build and predictive capability of both operational effectiveness, as well as predicting maintenance requirements and associated resourcing, represented by the visual and the predict bubbles. And so, relying increasingly on data-driven decision-making, the envisioned result is to create the optimal use of a client's investments. Not only use of the operational and support assets, but also of the support itself. That is, transforming maintenance from being viewed as an expense to being revered as an investment. Of course, this is a viewpoint we lobbyists have had for decades, right? Okay, let's get to the fun stuff. We can go to the next slide. As I'm sure you understand, each journey, IoT journey, unfolds differently for each client. So we wanted to highlight a range of efforts across both the federal and commercial sectors. In essence of time, though, I'll discuss only a couple of these. But let's start close to home with what we did with the Air Force Civil Engineering Center. This effort provided facility and asset managers access to analytics designed to optimize facilities, assets, and infrastructure through IoT technology demonstrations. With declining infrastructure health, emerging threats, and the recognition of Air Force bases as a critical mission element to combat air power, AFCAC was looking for a way to envision the base of the future. So back in 2018, they partnered with us to co-create and scope out a set of demonstration projects capable of changing and improving the way the Air Force manages the health of its critical facilities and infrastructure. From an initial list of 10 or 12 potential opportunities, we down selected the best of those options and kicked off some parallel squads at Andrews, Maxwell, and Barksdale to deliver on 4 projects that we co-executed with the Air Force reps at these locations. These efforts were associated with facility analytics, aerial visual recognition, IoT, building space optimization, and blockchain. The facility analytics project deployed sensors and machine learning predictive platforms to optimize facility use and energy across a range of building types. We put sensors on HVAC, electrical, and other energy systems, and were able to identify and predict utilization and energy usage that translated into opportunities for significant efficiencies and decision-making opportunities for improving the health of the buildings and the associated assets. Through the predictive maintenance insights, we demonstrated the value of automating the generation of work orders in their facility management system, TRIRIGA, without human intervention. So this is a long way towards showing how the Air Force can benefit from this kind of monitoring and automation. For the aerial visual recognition effort, we deployed drones to survey Air Force runways and collect images autonomously via high-resolution cameras. Applying artificial intelligence through visual recognition capabilities, we were able to identify cracks in the foundation, FOD, and other anomalies. These advanced insights allowed for preventative repair actions to be planned and executed, streamlining the runway maintenance process. And then lastly, the IoT space optimization effort installed over 300 occupancy sensors to measure space utilization across a range of facilities. We augmented this effort to leverage blockchain technology to demonstrate the quality, security, and validity assurance of the data that was transmitted from these occupancy sensor readings to our control center. So in just over 3 months, these efforts resulted in a demonstration of an IoT command center capability that provided real-time insights for various facilities types and infrastructure capabilities across multiple geographic locations, user levels, and data types. Along with that, we identified, roughly about $1.5 million in annual savings potential for just these 10 buildings and runways at the 3 locations. The work we had done was recognized in a DoD report to Congress on efficient and integrated military installations, as we really had demonstrated the value of these IoT capabilities to the Air Force facility management community. And now, as a result, many of these efforts are currently being pursued versus installation of the future effort. Okay, moving on to the next project is, I want to talk a little bit about what we've done with the city of Rotterdam. You may be aware that this is the home of Europe's largest and busiest commercial port by far. It spans 32,000 acres. That's equivalent to about 4 times the size of Wright Pat in square area. 150,000 vessels pass through the port annually. Cranes and containers locking and loading 24 hours a day. Needless to say, it's a big operation. Partnering with the port, IBM is installing IoT elements across this busy complex to improve the capabilities of various operational aspects. From a functional perspective, we've initially focused on assisting, let's say, 4 persona with enabling technology to improve their operations. The port control room commander, the maritime pilot, the digital twin director, and the Rotterdam Additive Manufacturing Lab director. Let's start with him, the RAM Lab. The Rotterdam Additive Manufacturing Lab's focus is on large-scale 3D printing of metal parts. Think propellers, hooks, impellers, parts for the port's energy generation systems. Clearly, the lab needs to guarantee the quality of its parts, which can only be done by monitoring the real-time process, monitoring the process real time while the printing is going on. And this printing process is essentially 3D welding, for which you need to tightly control the weld bit and the weld pool. And so when something begins to go off track, that can be directly detected in the data and the necessary adjustments made quickly. RamLab's welding system is connected to the IBM cloud, and all the data that comes out of it is stored here, and the controlling algorithms managed there. Their vision is to have a global network of RAM labs where you can print the parts nearby when and where you need them. Start the press on Friday, come back on Monday, and there's a print part.
Tom, sorry to
Process.
cut you short. We need to leave some time for question and answer. We have only 5 minutes left.
Yes, okay, so
Okay, so I will be asking the questions. So I'll start with Al. And Al, can you describe what are the typical reasons for businesses to, or organizations to adopt IoT? You're on mute, I think.
It's the most,
Is it 2021
most
or
used
what?
statement of 2021.
Being a moderator is like a school teacher, you know.
Thank you for that. Yeah, those are the words of 2021 for sure. So real quick, talking to organizations around the world, we see two sort of core types of initiatives where senior leadership has a specific goal and they're trying to implement it using IoT capabilities, whether it's cost optimization, a new product, a new feature to support their core stakeholder or the warfighter in the case of the DoD. So it's a leadership-led one. The other thing, though, that I see in other cases is actually where somebody at a mid-tier, but towards the stakeholder, the frontline stakeholder, sees a specific problem with the enterprise operations, and they try to figure out a way to make it more productive, improve the process, or actually do something they couldn't do before. So these are the two sort of vectors that I see for the majority of the IoT initiatives that I see across the board. And again, this would be all industries and from Qingdao to Calgary to New York.
Thank you. And Jan, what's the best way to get started with IoT?
I guess my advice to people is always start small. So take a crawl, walk, run approach. It's quite affordable to start on a journey with IoT, and maybe initially it's just a few machines in one shop, so you can kind of understand the type of data that you're able to expose, and then looking at that, the real small elements of that you actually care about as a shop owner or a production manager. Understanding then the IT challenges that may come with the enablement of that communication inside your organization. And once you understand those things, you can start to build that roadmap that Al referred to earlier. And that can be a multi-year roadmap, but getting started is actually something that's relatively easy to do.
Thank you. And Tom, this question is for you. Can you share some of the experiences from commercial clients that can benefit DoD's IoT strategy and operations?
oh, sure, of course. I think there's lots of places, things that we've talked about over this panel, and I'm getting some feedback. Can you hear me okay? Along the lines of what Al and Ian were saying is, yeah, the value is there in monitoring asset performance, being able to score asset operational effectiveness, and being able to predict asset management requirements. Pulling this together into an intelligent set of workflows. It really opens up, unlocks the effectiveness of the systems that the DoD manages today, the processes, and improves the asset availability, and really everything we've talked about in the commercial sector over the last few days certainly does apply to the Air Force DoD industrial capabilities as well.
Thank you, Tom. And Al, another question for you. Who is responsible for governance of IoT?
Uh, well, so this is a blended answer. Governance is usually driven, in my experience, by IT folks because they really have processes and structure for it. However, governance requires funds. And the way we see this operating in the real world is a senior business leader owns the funds, makes sure that somebody's actually driving it. So it's owned by the business leadership, but it's usually implemented by a blend of IT, but also the operations team.
And question for you, who owns the data from the IoT project? The IoT is all about data, right? Yeah. So who owns the data?
I guess the organization that's generating it, and how widely you want to share that, I guess, is up to the business leadership that Al spoke of that should ultimately own that program. Because the IoT program may have had a specific objective in mind. That objective may have been increasing throughput of a factory or a depot. Once that's been met, then if other business benefits can be achieved through sharing that data more broadly, then there's probably some good reasons to do that.
And I know the time is almost up, but I'm going to take 30 seconds and share one experience with you, because I have been involved for many years designing and implementing a smart cities, a smart airport, smart health, connected hospitals, and hopefully in the future take all of these lessons learned to a smart base. When we designed the reference architecture for a smart city, which is fundamentally a digital transformation of the government at the local level, what's the bottom of the reference model? In our conceptualization, that is the digital platform. And that digital platform fundamentally is the IoT platform. So with everything is smart that we are building, a smart infrastructure we're building, you will see that that is going to be the driving force, because I'm an architecture-driven guy. I'm not a technology-driven guy. I don't believe in technology. I think architecture is the most stable aspect of an organization as the data, and therefore digital transformation, even in digital transformation, we should really focus on architecture. Having the right architecture will solve the technological issues. So if there is any burning thoughts or feedback from the audience, we'll be happy to have it. Otherwise, we thank you.